Bless you. Okay. Get frozen. Well, I suspect some of you are done. If you are, feel free to pass your paper over towards the middle. I'm just finishing up myself. Whoops. Okay. Let me come get what you have here. Is this one mine too? This all? Okay, great. Oh wow, look at you. Nice. I'll come back. Don't worry. Little stack here. Good. It's all right. I'll come back for you. Oh, extras. Thank you so much. This one good. All right. Let's see. Extras. Ooh. Yeah. Yeah. All right. Thank you. What's that? 1, 2, 3, 4. That. There's 3 there. Okay. Thank you. So 1, 2, 3, 4. There's those. One. Another. And another for you. Okay, I think I got all the quizzes. Is that right? Amazing. Okay, let me just staple these together. I forgot to bring the ones from last time, so I'll have to bring those on Monday when I return these. Good, okay. All right, let me show you my answers. Hopefully they're correct. If they aren't, you can always let me know. Oops. Okay, there we go. Okay, so first things first, which one has the smallest mean? The mean, of course, of these 4 is the one with the hump on the furthest to the left, so that's A. And then which one has the biggest mean? It's the one with the hump the furthest to the right, which is D. And then in terms of standard deviation, smallest standard deviation will be the one that's the most crunched together. So this direction, so that pushes it way up, which is C. The largest standard deviation is B because it's spread out the most. And then this, pretty straightforward. Just wanted you to remember that we're interested in these 2 numbers, the normal curve where the mean is 153, the standard deviation is 14.5. And then this particular game, 175, there's the formula up there. I got 1.52. So this should be easy to grade because I'm pretty sure everyone got 100% on this. I've given you each a piece of paper that has normal curves on it. Let me see if I can find that in my, I don't need to find it. Hey, welcome. Uh, I'll give you one of these too. Yeah, we're not doing that. Sorry, that's from someone else. Here you go. This is for today. So we'll be using Excel today. If you want to, you don't have to follow along with your Excel. It's not essential. After the break, there will be times when you definitely want to have Excel going. Let's see, is this the one I'm supposed to be doing? No, just a minute. I should always have it open. Normal distributions. Is this it? This is it. Yes, this is it. I think. Yeah, close enough. Just a minute. That doesn't look right either. I have to check. You know, it doesn't always update the way I want to when I go over to the iPad. So let me see what I have here. But anyway, yeah, after the break, we're going to be doing quite a bit of work with Excel. And so you're going to want to definitely have your computer each day. Let me just see, is this the one? No. You would think that I would have this up here. Normal distributions. Close enough. Yeah, we'll use this one, I guess. It's just not what I was expecting. Okay, Z-scores. No, this isn't right. Sorry. Pause for a minute. Let's see, normal. Why can't I find this here? So weird. Oh, here it is, finally. I don't know why I couldn't find this. Okay, now I've got it. Let me go back. So give me a sec. It should update. There it is. That one is the one we want. And here, let me just fix that. I'm sure I fixed this at some point in the past, but we're going to fix it now. Come on. Okay, there we go. Okay, so put this up here. We're going to be doing normal probability distributions and specifically calculating the probabilities. And this is supposed to be these symbols here. We're going to be computing probabilities for specific normal curves. And we're going to use Excel for this. So I've given you each a sheet of paper with a bunch of normal curves on it. If you want another one of these, like let's say you use this and you're like, oh, this is a great tool. I've got it up on our Moodle page in the homework section, right? I think either before or after Monday's homework, you'll find this printable normal curve. I've got a few extras up here if you really want one after today, if you think it's really good tool. So what we're going to be doing is we're going to be computing probabilities on a normal curve. So for example, the easiest, oh, wait, before we do this, let me just mention that these are the tools. These are the functions we're going to use on Excel. And once again, if you don't want to have your Excel open, it's okay. I have mine. It's back here. Let me make sure that it's available and ready. There it is. I'll zoom all the way in there so that we can actually type some of this stuff in to see how it works. This is going to feel similar to your calculations of the binomial distribution. You just have to know which parameters go where. And so we will work with this. And of course, Excel is nice. It helps us to do this. So we'll basically be doing this using a series of examples. And the first example is just this, is that you can imagine a machine that fills bottles with soda or something, and it's programmed, or it's calibrated to fill the bottle with 32 ounces of liquid. But of course, it's not always going to be exactly 32 ounces. It'll sometimes be a little bit more, a little bit less. So we want it to be as close as possible to 32. And so maybe whoever built this, they've figured out that there's, it sometimes is a little bit more, sometimes a little bit less, but the mean is 32 and the standard deviation is 0.02. So let me do this first one for you because we haven't really focused on this much, and then I'll have you answer the rest of these. I've got a series of questions based on this. So x is the amount. So think of x. I know you don't like the letter x, maybe not most of you, but some of you probably are scared of it because it's the thing that tortured you back in algebra. But this is just a letter that we're using to represent what we're measuring. So what are you measuring? You're measuring the amount of soda in one bottle. So you choose a bottle. The amount in that bottle is going to be X. And of course, it's X because we can't predict exactly how much soda is in the bottle, but we can say that on average, there will be 32 ounces and on the standard deviation. So it's not very spread out. Standard deviation is 0.02. So now that we've got that out of the way, let's talk about the normal curve. So this X, this amount of soda in the bottle, is normal. And you already did this for me on the quiz, but this will give me a chance to get this thing fired up here. Let's see, random student. So Sarah, what are the two numbers that you're going to put in here to describe this normal curve? Yeah, so the mean is 32 and the standard deviation is 0.02. And I realize that this feels really redundant. We've already got this information up here, but it's good to summarize it in one place so that you can use the information when you need to. So the next thing, I want to find some probabilities. So let's go ahead and find some probabilities. Find the probability that the bottle contains less than 31.95. Now, ounces. Now, I need to, let's see, I'll go to Moodle. Let's see, that's not Moodle. That's something else. Let's see, courses. So I'm going to show you. Just a sec, log me in here. Sure. Trying. There's the cougar. Okay, so if you go to Moodle, you will find statistics. Here we are. Under homework for February. Yeah, it's getting a little bit long up there. But under homework for February, the homework that is due Monday, you'll see two of them. I know it's kind of annoying. Oh, I need to mention something about this. Someone talked to me after class. I forget if it was Wednesday or Monday, that that they got pushed into, what are they called? Like review topics. And so if you ever get bumped from whatever topic this is, so this is going to be like calculating the mean and standard deviation of a normal distribution. If you get enough of those wrong, it'll push you into like these review topics, and some of those topics might be kind of foreign. And you might like, why do I need to do this? You should be able to skip them. I've got these set up, so if you ever get into one of the review categories and you can't figure out how to skip them, there should be a place up at the top that you can skip of the screen that you can skip the review category. So just so you know, that hopefully will work. If it doesn't, let me know and I'll try to change the settings. Anyway, getting back to this, there are two things that are going to be useful to you: the normal curve template and the normal curves printable. So the normal curve template is an Excel file. I will show you that in a bit. I'll just get it open up here on this. There we go. But the printable one, that's the one I wanted to point you to because this is what you have in your hands. Also, that way I could move it over to Notability and use it right now. Okay, so here's what you're looking at. You're looking at these curves. Technically, this isn't exactly a normal curve. The normal curve would actually be much closer to the x-axis way out here at the two tails, but I wanted to make it high enough that you could actually sort of see that there is a gap. So it's not exactly the normal curve, but it's close enough. So let's deal with this bottle problem. The bottle problem, so what you're gonna do is on this piece of paper, you can keep sort of, this is example one, maybe. Example one, problem one. So we can keep track of what's what. And so for this one, the bottles have a mean of 32. So I've got these marked off relatively nicely for you. The mean is 32, and those other lines are actually your standard deviations. So this will be 32.02, this will be 31.98, this will be 32.04, 31.96, and so on. You don't have to mark these off. By the way, you'll have next week on the test, and actually on the test after that, and the final exam, you'll see these normal curves on that. I don't make you draw them yourself because I've seen the kind of artistry that you guys do, and I don't like it. So I figure I make it myself, and then that'll avoid everyone frustration. But you'll see these, and when you see something like this, don't leave it blank. What you want to do with it is, at the bare minimum, you're going to do this. Put the mean at the middle, and then mark any other number that is important for the problem. So when you see a normal curve like this, don't leave it blank, do something with it. Okay, so here's what we're going to do with this one. I'm interested in the probability that my bottle is less than, what was it? 31.95. 31.95. So this is the problem that I'm trying to solve here. What is the probability that my bottle is less than 31.95? So what I'm going to do is, on my normal curve, I'm going to mark where 31.95 would be. Notice that it's a little bit below 31.96. And then I'm going to shade the appropriate area that represents that probability. You see, when you're doing statistics, if you want to compute a probability, probabilities are computed using calculus, and specifically we want to find the area. That's the beauty of this curve. This curve has embedded in it all of the probabilities that we need, and the way we compute them is by computing the area. So this will give you a clue, and by the way, you're not going to use calculus, you're going to use Excel. This gives you a clue as to what the answer is. Take a guess as to the percentage of the overall area. So the whole area is 100%. So just take a guess as to what percentage was just highlighted there. In fact, I'm going to take a guess. No, I'm not. I'm going to have you guess for me. So this is not necessary, actually. You don't have to do this, but it's kind of fun to think about. Elizabeth, what would you guess is the percentage of the overall curve that I've just shaded over there? Is it a big number or a small number? It's a really small number. So it's like, is it going to be 10% or 2% or maybe a 0.5%? Like 2%. Okay, I like that. So 2%. So Elizabeth is like, it's probably 2%. Now here's the thing, Elizabeth isn't right, but it's a good guess. It's in the ballpark. And the reason I'm asking her to do this and I'm asking you to do this is, when you do this, you say, hey, I think that that's going to be about 2%. And so if you get an answer like 90%, it should clue you in that something is wrong. Either you've drawn the picture wrong or you've done something wrong with your calculations. If we get an answer that's close to 2%, like 1%, I think we should be pretty happy with Elizabeth's answer, her guess. So let's go ahead and see how we're going to do this. So going back, I know I keep switching back and forth. I'm just going to go back to this. So we're going to use this. This is going to give me the probability that I'm looking for. So let me just show you this in, here it is, so that you can see what this looks like. I guess I could move this maybe down. Can I move it down? No, I like where it is. I guess I can do that. Oh well. Okay, so if you're using Excel, it's going to be equal to, just may not be able to see. Okay, so it's norm.dist is the function. Here, let me just make this a little bigger for you. There we go. So norm.dist, and then in parentheses, we put the number we're interested in, 31.95. Then we put the mean, 32. Then we put the standard deviation. And then we say that we truly want to know the answer. So we say true. So actually, that's not exactly why we say true, but you don't need to worry yourself over why it's true. Just think of it as, I truly want to know the answer. So with the binomial distribution, we always say false. And once again, you don't really care why. We're just going to do this. So it has to do with the fact that there are two different ways of interpreting the normal distribution, but we want the true version. So then we hit enter. We just get rid of that, hit enter, and there's my answer. So it's 0.00621 is the correct answer. Let's go compare this and see how we did. Here's the iPad. Here's my thing. Okay, so the actual answer, and I'll even write this down, norm.dist. You don't have to write this down, although you might want to. 31.95, 32, 0.02, and true. And I got 0.00621. Is that what it was? Yeah. Which is approximately 1%. Hey, Elizabeth did great, didn't she? She's pretty close to the actual answer. I know you might say, well, it's actually not quite 1%, is it? Well, close enough. I mean, yeah. And also, I should confess that because of the way I drew this, the area would actually look smaller if I had drawn the curve correctly. So I just want you to be in the ballpark with these. All right, let's try another one of these. Problem 2 from this, whoops, not that, just a sec. Problem 2 from this particular example is right here. There we go. Or I guess it's problem 4. I don't like problem 4. Let's go on to problem 5 just for a minute. 31.97. 31.97, it says find the probability that the bottle contains more than, we'll get to 4 in just a minute, but let's deal with more than 31.97. So let's go back here to our picture, more than 31.97. So we have the same, all the rest of the stuff is the same, it's just that I'm trying to find the probability of being greater than 31.97. All right, so draw on your picture, so you've got a new curve, put 32 in the middle, put 31.97 about where it's supposed to be. I think I'll put it right about here. Let's see, right about there. Is that about where it should be? And then shade, kind of like what I did up here, highlight the portion of the curve that we're interested in when we say more than 31.97. Take a minute and see if you can get it. Let me go ahead and shade what I think we're interested in. I'll do this with a highlighter. Give me a sec here. So it's all of this stuff over here. Take a minute. There we go. How's that? So does that make sense? We're going more than now instead of less than. Less than looked like this. You were going off to the left. More than, you're going off to the right. Okay, so make sure I'm on track here. Let's pick another volunteer to see how we do this. So another guess, Caleb. Caleb, if you had to guess the percentage of the area that I just shaded, what would you guess? About 90%. I like that. 90%. So here's my guess. So, and once again, I'm not so interested in you getting it perfect. When you write down a guess, it's just to remind you or sort of give you an idea of, well, what's the answer going to be approximately? 90%. That sounds about right. Looking at the picture. So if it's 95, I'm pretty happy. If it's 85, I'm pretty happy. But if I get 10%, then I'm pretty sure something went wrong. Okay, so let's pull up our Excel. And here I'm going to try to get this so I can see both things. Okay, I can see most of this. And so just a sec there. Okay, so there, now I can see a lot of it. You know what, in my Excel, if you're following along, you know what you might want to do is this. So let's insert a column. There we go. And so then I can write down, this is the probability, just to keep track, the probability that X is less than 31 point, was it 95? Was that the last one? Yeah. So that number there, that number was the probability that X was less than 31.95. Now we're going to do the probability, let's put a gap here, I guess, the probability that X is greater than 31.97. Okay, so let's do the same thing, equals norm.dist, and then we have 31.97, and 32 is the mean, and 0.02 is the standard deviation, and we truly want the answer. Hit enter. Hold on a sec. Now, Caleb said that he thought the answer should be about 90%. This is about 7%. So when I get this, I know something went wrong. Either Caleb is wrong about his evaluation of this picture, or I made a mistake. So let's first of all deal with Caleb, because of course, you know, why would I make a mistake? What do you think? Do you think Caleb's about right in his guess? Did anyone have a guess different from Caleb? I mean, very different. So you're all in the ballpark of 90%? Okay, so probably I'm at fault. And in fact, I am at fault. The reason that I'm at fault is because of this function here. You see, Microsoft was founded by Bill Gates, and Bill Gates is a leftist. And so if you remember that, you'll know that this particular number here is not going to be the area to the right, but area to the left. So I joke a little bit about this, but it is helpful to remember that Excel, Microsoft, Bill Gates, leftist, stuff to the left. So the area there is actually the stuff to the left, not the stuff to the right. In fact, every calculation that we do with Excel, just remember, Excel is leftist. And then that will help you to do the correct answer. So I've moved that up a little bit just to emphasize. So this is X is less than 31.97. The left, to the left. The reason, by the way, the reason that Microsoft and Excel is leftist is not because of anything political. It's because of the mathematicians who helped Microsoft write this. So it all makes sense mathematically, but it's kind of funny to think of it in terms of some political agenda. Okay, so now we need the stuff to the right. Well, here, to help us figure that out, notice that this area over here to the left is about 7%. So what's that going to be? 6.68%. So that's that area. Oh yeah, I can't really zoom in any further. So that's that area. What I want is this area right here. Well, if the whole thing is 100% and this is about 7%, then this is going to be about 93%, right? So to get that area, what I'll do is I'll just take 100%, 100% minus the 6.68%. I can do this in my head. That's going to be 93.32%. But let's do it on Excel just to show you how that's done. So on Excel, what it's going to look like is this. Whoops, not that. This. So we'll do equals 100% minus. Now, either you can do percents or you can do numbers. I don't care how you do it. I'll do it both ways just to prove that it works both ways. So I'll do 1 minus this. So 1 minus that previous answer will give me the correct answer. Or if you prefer, let's just do this. You could do equals 100%. But if you do the percent, then you better put that percent symbol on your Excel. Otherwise, you'll get it wrong. 100% minus that number. And of course, then it gives it to you as this big, ugly, wow, so many digits. But I'm happy with either one of these. So this is 0.9332 or 93.32%. Whichever one you prefer is fine. I think probably that, in fact, I'm almost sure that Newton will prefer this, the decimal. So just do whatever Newton wants you to do. All right, any questions? Yeah, what do you think, Hayden? I sure can. Cell B3 is that one. So I am always going to do this way. What I mean by this way is I'm going to compute the probability to the left, and then I'll do 100% minus that to get my probability to the right. It is possible to do this in a single step. I'll write it down over on the iPad. It would be 1 minus norm dot dist of 31.97, 32, 0.02, true. So you could do this all in one thing. And no, you have to have equals at the beginning of this. So if you're doing this on Excel, make sure you put an equals. Otherwise, Excel won't know that you're doing a formula. All right, anything else? By the way, what Hayden just asked is perfect. If you're confused about something, or if you need me to see one of these cells, just say, hey, I need to see cell B4, and I will do, there is cell B4. There's my formula. So Hayden, did you have another question? Interesting. Let's go back. What do you mean by completely different? How different is it? Yeah, that's wrong. So it should be norm dot dist, and then the first number is 31.97. 02. Yeah, see, you got to get all the zeros in there. Now you're happy? Now he's happy. Yeah, so this will happen though. So after the break especially, we're going to be doing a lot of Excel. So be patient with one another, be patient with me, and we'll get through this together, because there's going to be a lot of this. Like, I'm off by a factor of 10, and then we'll figure it out, and we'll move on. It'll be okay. I've already budgeted the time. It's fine. Anything else before we move on? All right, so it looks good. All right, we got a couple more, and then we'll move on to a different type of problem. We'll be done with the bottling problem, which we're probably all sick of. Okay, give me a sec here. So let's go back to that number 4 up there. Find the probability that the bottle contains between 32 and 32.025 ounces. Okay, so we're back to this picture. Whoops, let's get the picture up here. Nope, there it is. Okay, so between 32 and 32.095, or whatever it was, I'll figure it out. So 32 goes in the middle, always. But then I need to put, what was it? Just a sec. 32.025. Okay, so this would be 32.02. So apparently this, 32.025. There you go. There you go. So here we go. This is what I'm interested in. I'm interested in this area, the stuff between those two numbers. Let me write this as a probability statement. So here we go again. Let's take a guess. What percentage do you think this particular area is? Take a guess, and I'll pick a random person to tell me what their guess is. You're not here. You could have known. Well, Karen, what do you think? What percentage of the entire would this be? Did you say 35? All right, I like 35. So just a quick note, 35 I like. I'm going to write down. Just want to point something out, that this is right in the middle. 32 is right in the middle. So you have half of the distribution to the right, half of the distribution to the left. And so this will be less than half. I just wanted to point that out, that if you think that's 60%, no, you're wrong. So I like Karen's answer, 35%. Is that what you said? Yeah, let's put that down as our guess. Let's see how close we are. You might think it's different, but when I say I want you to be in the ballpark, it just is close to 30. Like, if you get a number like 80%, then that's not close. If you got 5%, that's not close. So If it's somewhere around there, then I'm happy. So the guess, though, it's not the answer. The guess is just to help guide you when you're thinking whether or not you got this, made a mistake. So let's go ahead and go over to Excel and see how we do this. Now remember that Excel is leftist, and so the only thing that Excel can do is it can give me the probabilities to the left of my number. So what I'm going to have to do is I'm going to have to kind of piece this together. So I'm going to do this. Probability that X is less than 32.025. And then I'm going to do the probability that X is less than 32. And then hopefully I can piece those together to get what I really want, which is between 32 and 32.025. So that's sort of the roadmap. And actually, now that I've done a few of these, what I could do is I could just copy that formula and paste it in here and then fix it. So the only difference is I have 32.025. There it is. So there's my probability of being less than 32.025. And I think if we had shaded from here all the way over, I think we would all agree that's a pretty good guess, 89%. Okay, now let's do the same thing, but for the probability that X is less than, whoops, sorry about that, less than 32. Give me a minute here, I have to fix this. Let's delete this stuff, whoops. This shouldn't be a big surprise. Some of you might have said, why are you even typing this in? You just told us that 32 splits things in half, so certainly half of the distribution is to the left. Kind of makes sense. Now, how to get the stuff in between? Well, one way to think of it is that we have the entire curve. Let me do this. You don't do this yourselves, but I will do this down here. Let's see, here's 32.025. So here's there it is. This is the 89% that we got. And then the 50%, let's see if I can fix this. Give me a sec. I have to change my pen. Okay, so the 50%, what that is if we were to get rid of the 50%, take all of this, and then subtract off this, essentially what we would do is we would be getting rid of all of this stuff over here to the left. So so that's my strategy is I'm going to start with the 32.025, that 89%, and then subtract off the stuff I don't want. So let's go do that in Excel. It looks like this. I'll take the bigger number minus the smaller number, and there's my answer. Let me move this over just a bit. There. So 34 or 39%, that's pretty close to what Karen had suggested. Pretty close to the guess. So I'm pretty happy about it. So let's see, change this back. Give me a sec here. Okay. All right, any questions about that? So basically you're just going to subtract one from the other. All right, we have one more type of problem, and then we'll see if there's any more time to do more problems. Let's see, is this? Nope, that's not it. Just a minute. We don't want that. We don't want this. No, that's redundant. So I'm just looking for an example that's different. This is, no, that's boring too. Here we go. This is a good one. All right. Yeah, let's take a look at this one. Let me get this off here. Okay, and if we have time, we can roll back and go do the other ones, but this will help us with the rest. So let's go through this. We'll fill in the blanks. We'll identify X in words, then we'll fill in the blanks, and then we'll get these probabilities. And it's numbers 4 and 5. Those are the two that I want to make sure we focus on because those are different from the other problems. So starting off, identify X in words. What are we measuring? Go ahead and jot down what you think we're measuring. And, if you want to, you could always, since we've done the bottle problems over here on the left, you could move over to the right and do the house problems household income problems over here. So see if you can write down, what do you think that we are measuring? Okay, so I'll write down what I think we're measuring. We're measuring, so X is equal to the household income of one house in this community. I should say that I probably typed this up 20 years ago, and so that's why the numbers are so low. So I'm sure this is like a poverty-stricken community at this point, but it was sort of typical 20 years ago. Okay, so normal distribution. Let's fill in the blanks. Let me find a rando to help me out here. I should just move this over just a sec. There, this will be easier for me. Next. All right, it's better. I feel like I've already picked on you. All right, Gracie. Gracie, what do I fill in the blanks with for this thing? All right, very nice. And 8,000. Now, I need to mention something about this, and that is that you have options. So if you don't like all the zeros, you don't have to keep all the zeros. You just have to keep track of what you're doing. So this is one way to do it. Another way to do it is to do this, 28, 8. So if you prefer not to type all those zeros in when you get to Excel, certainly you can do this. The only caveat, the only thing that you need to remember is that now, instead of measuring household income in dollars, this over here is measuring household income in thousands of dollars, which would mean that this is no longer 40,000, it would be 40 if I did it this way. So just to let you know, I'm going to do it with all the zeros, but this is an option if you are confident that you can interpret this correctly. So in other words, when you do this, you would have to interpret everything in terms of thousands of dollars. So let me erase those. I just wanted to give you that option if you were so disposed. So let's, oh no, come back. Okay, I have to be careful about erasing. For some reason, it sometimes thinks I'm trying to advance my slide. Okay, so let's go ahead and go to our normal curve. That one looks terrible. Let's go get a better curve there. Aren't they better over here? I'm going to move over to the other column, even though I still have one at the bottom. So we'll start with this one. It said that the household incomes have a mean of 28,000. So here is a good reason why you might want to just use 28 instead of 28,000. How am I going to write this 28,000? I could rotate it like that. I suppose I could have just written it really small, couldn't I? Like, maybe I could just do, well, it's not behaving. Yeah. Yeah, you decide how you want to deal with it. 28,000, and I forget what the standard deviation was now. Back here, 8,000. Okay. Back to this. So 8,000. So even though it's not necessary, it's kind of nice to have the sort of locations of these things. So you might want to just put in one standard deviation. If you do 28,000 plus 8,000, you get 36,000. And of course, 28,000 minus 8,000 is 20,000. Okay, next I'm going to put in my my number that I'm interested in. It says that we're interested in 40,000. 40,000. And let me just put that back up just for a sec. And so the next person that I ask, what I want to know is, are we shading to the left or to the right for this particular problem? So give me a sec here, put this back up here. So number 3 here, what's the probability that a household selected at random has an income greater than 40,000? So do I shade to the right or to the left with that? Let me put this back up. All right, so Carson, what do you think, left or right? More than 40,000. I'll write down the probability statement even. Very good. So this is to the right. So here we go. To the right. To the right. Okay, beautiful. Next, we're going to just take a guess. And once again, you're probably not going to be writing this down. I'm going to write it down just so I can remember what you guessed. But it's not essential. It's not part of doing the solution. It's just for you know, I like to do this just so I can think, you know, did I get the thing right? Okay, so hopefully you have a guess as to the percentage that I've got. Biella, what do you want to guess for that green sliver there? 25%. All right, I like it. 25%. Okay, so that's my guess. And then, you know, I might have guessed, you might have guessed something different. I actually would have guessed more like 15%, but that's irrelevant. I just need to have a ballpark guess to say it's going to be something smallish, but not super small. That's what I like about this guess. It's not 90% and it's not 2%. It's something, you know, small. It's less than 50%. So we would all agree with that. So let's go ahead and see what this actually is. So going to Excel, let's see if I can't do that. I guess I'm going to have to, I know what I can do. Hold on a sec. Okay. Ooh, I'll show you this in a minute. So this will help me to adjust. Let's see, where is this Excel there? Yeah, that's it. Okay, give me a minute. Okay, so I'll show you what I had up there in just a minute, but I needed to move it over to the left there. Okay, so where's my? There it is. So down here somewhere, I'll do the probability that x is less than 40,000, because of course Excel is leftist. Oh, I shouldn't put the comma there. Sorry. You can put the comma there if you want, but when you're typing things into Excel for your formulas, you definitely don't want those commas. So this is going to be norm.dist of 40,000, don't put a comma, 28,000, don't put a comma, 8,000, don't put a comma. If you don't like all those zeros, whoops, I forgot the true, comma, true, there. So let me make it so you can see the whole thing. There it is. So there's what I typed in. If you don't like all the zeros, you could always just switch and think in terms of thousands of dollars, in which case you would dispense of all the zeros and wouldn't have to have a comma. But here's what I got. Obviously not the right answer because it's too big. Biella says 25%. This is 93%, way too big. So, but we knew that this would be the case because Excel computes areas to the left. And so what I need to do is I need to just subtract from 100%. So this is equal to 1 minus this previous answer, and that gives me this. So about 6 points. So actually we were both off by a bit, but that's okay. You know, on further inspection, and this is also the case that I've exaggerated the distance between the x-axis over here. So this isn't a super accurate curve, but it's in the ballpark. I'm happy with both Biella's guess and with my guess, because the guess isn't really what matters. The guess is just supposed to tell you sort of, it's probably going to be somewhere around there. It was a little less than both of us had predicted, but I'm happy. I think that this is correct, 6.7%. So the guess is only to try to help you detect mistakes in your work. It's not part of the actual answer. Okay, so there it is, 6.6% or 6.7% is the correct answer. So however it wants it to have it. Okay, so the last two more problems. Wait, not here, just a sec. There. So two more problems, numbers 4 and 5. Take a look at these. Both of these are kind of like Jeopardy. You know Jeopardy, where they give you the answer and you're supposed to come up with a question? So with these, it says something about the percentage and you're supposed to figure out where the cutoff is. Same thing here. This is asking about a percentage and you're supposed to come up with the cutoff. So let's see how we would do these. Let's do the 75th percentile first. I know I'm going backwards again, but that's okay. So whenever you're doing these, as before, what we're going to want to do is put our numbers in here, 28,000, and then this is 36,000, and this is 20,000. So we've got those. But notice what it's asking for is it's asking for a percentile or a percentage. And so what you're going to do is you're going to draw your line. Remember that Excel is always going to be leftist. So 75th percentile would be something like this. It's the place where 75% of the households are less than that, and 25% of the households are bigger. So that's what 75th percentile means. So that's how I'm going to draw the picture. And so here, that's the thing that I don't know. I don't know where that red line belongs. In fact, I probably don't have it in the perfect location. You might have drawn it a little to the right of 36,000. But either way, wherever it is, you know that the number is going to be somewhere near 36,000, maybe a little less. In fact, I know it's going to be a little less because I've done this before, but this gives me a clue. And so my guess, which I'm not going to write down this time, my guess is that it's probably about 32,000, 33,000. So let's find out if I'm right. So Excel has a way of doing this. Instead of doing norm.dist, you use norm.inv. So that's the way that we're going to set this up. Let me grab Excel so that we can actually do this. There we go. So I don't know what to say about this. So I'll do this 75th percentile, just so that we can keep track. If you're keeping track on Excel, you might want to type in your notes and so forth. Okay, so this is going to equal norm.inv. Let me make this big so that you can see it. Give me a sec here. There we go. So norm.inv, open parenthesis, and notice that it gives you some, it's hard to see pixelated, but it says probability. The probability is the probability to the left. You can either type this as 0.75 or type it as 75%. So however you do it, as long as you have the percent symbol, you're okay if you do 75%. So that's always going to be the percent to the left. So notice on my picture, the percent to the left of my answer is 75%. Okay, then it asks you for the mean, which we know is 28,000. And the standard deviation was 8,000. So that's what we'll do. Hit enter. Look at that. I was pretty close. 33,395 is the correct answer. So that's the right answer here. Let me just write this down in case you're keeping notes yourselves. So norm.inv, and then we would do 0.75, and then 28,000, and then 8,000. So something like that, just to keep track. And then the correct answer is 33,395.9. I suppose you could round it. By the way, Newton is inconsistent with their rounding. Sometimes they say round to 3 digits, sometimes 4, sometimes 2, sometimes none. Whatever. Just make sure you round, because if you don't round to the right number of digits, they can be unforgiving, let's just say, in their, even though you're right, technically, they're like, oh, not right. It's really annoying. So just be careful with that. Okay, one more, and then we're all done for the day. Whoops, that's not what I wanted to do. This is what I wanted to do. Let me just go back here to PowerPoint land. Notice number 4. It says, what income would correspond to the highest 1% of households? Highest 1% of households. Let me go down here, get this set up again. 28,000, 36,000, 20,000. Now, here's where I need you to go ahead and see if you can figure out where the line would be for the highest 1% of households. Where would that line go? Take a guess. Oh, do you have or do you have a question? Oh, you have the answer. Okay, give me a sec here. All right, Caleb, where do you want to put this line? Okay, you did it on Excel? Okay, nice job. But we're just doing setting it up yet. I'm sure you're right. Okay, very nice. So I'm guessing that Caleb probably put his line somewhere over here. Is that right? Yeah, so you've got your line there. Now, here's the thing that I want to point out, because this gets, a lot of students make this mistake, is they'll put the line way down here thinking that they want 1% over here on the left. But it says the highest 1%, which means the 1% is over on the right, 1%. And that means that 99% is over here on the left. So be careful of this, but then let's do what Caleb did. It'll just take a sec. So I want the highest, so highest 1% will be equal to norm.inv, and I'm going to use 0.99 instead of 1, not 1%, but 99%, because the stuff to the left, Excel is leftist, stuff to the left is 99%. And then the rest, let's see if he's right. I'm sure he is. 8,000, close, 40. Is that what you said, Caleb? Nice work. So that's the answer. That's the cutoff. So that's going to be, this is probably going to be the worst, is when you have to interpret something like that. And sometimes the English is the problem. It's not so much the math. All right, well, that's it. I'm going to stop the recording if you want to come talk.